This video is on basic shifts of a quadratic. In previous video, I have explained what the a value does to a parabola. If an a value is negative, then the parabola will flip over the x-axis. If the a value is between or smaller than 1, then the parabola will be wider because of vertical compress. And if the a value is bigger than 1, then the parabola will be more narrow or skinnier because it's called a vertical stretch. So what happens when you have something added or subtracted? A c value, a constant on our quadratic equation. This is the c value. When we plug our numbers in, we want to see what really happens. So we have our parent function of x squared, but we're adding something to it. So this is no longer a parent function. We know that our parent function had the coordinates of 0, 0, 1, 1, 2, 4, 3, 9, and we had the symmetry of that at the negatives. So what really happens when we add something to as the constant? So if we find our coordinates, 0, the x value of 0, when we square it will be 0, but now we're adding 2 to it. So 0 plus 2 is 2. So our first coordinate is actually at 0, 2. The x value of 0, we got the 2 from the y. So that's already changed from the original, from the parent function. So let's plug in the 1. 1 squared is 1, but then we have to add 2 to that, which we get 3. So our coordinate will be at 1, 3. Let's check the negative 1 to see if there's symmetry. Negative 1 squared is positive 1, plus 2 is positive 3. So we do have symmetry. So this has been different from the parent function. It's actually shifted. It's no longer at the origin. It's now up higher. So let's do 2. X value of 2. 2 squared is 4, but we have to add 2 to that by getting to 6. So we have symmetry here, so we know we should be at negative 2, 6 as well. Let's do our 3. 3 squared is 9, but now we have to add 2 to that, so we get 11. And with symmetry, we have negative 3, 11 as well. This is our new parabola. What really happened? The parent function over here on the left started at 0, 0, but now this starts at 0, 2. We can see that all of these coordinates have actually been shifted up by 2 units on the y-axis. The x's are still the same, but the y values have shifted up because we added 2 after we plugged in our x. So what happens when we're subtracting 3? So we still have x squared, so we have no a, the a value is 1, so it's not going to get wider, it's not going to get narrow, it's not going to have a vertical compress or stretch. So what happens when we have a negative 3 attached to it for your constant? If we plug in our values, so we start with 0. 0 squared is 0, but then it says we have to subtract 3, so that goes down to 0, negative 3. So that's different from our parent function. It started at 0, 0, but now it starts at 0, negative 3. Let's plug in our 1. 1 squared is 1, but it says we have to subtract 3, so that gives us 1, 2, 3, a negative 2. Let's see if there's symmetry by plugging in negative 1. Negative 1 squared is positive 1, but we have to subtract 3, which gives us that negative 2 again. So there is symmetry. So 2 squared is 4, but it says we have to subtract 3, which gives us a 1. And with symmetry, we can use negative 2, 1 as well. Let's try the 3. 3 squared is 9, but we have to subtract 3, which gives us 6. With symmetry, we have negative 3, 6 as well. And it looks to be that would be the last of our on the graph that we can fit. So it did not get narrow, it did not get wider, so there's no vertical stretch or compress. It did not flip because our a value was still a positive 1. So what happened when we subtracted 3? From the parent function, it started at 0, 0, but all of these coordinates seem to have been shifted down 3 spaces on the y-axis. So when you add or subtract a number on the end to where your constant is, it looks like the graph is moves up or down. So it moves up when you're adding a C value, and it moves down when you're subtracting a C value, when your constant is positive or negative. So let's look at what happens when we have an A value and a C value that is different than the parent function. So if we think about what this might happen, a negative A value tells us that our graph should point down. An A value of a 2 tells us we're going to have a vertical stretch, meaning it's going to be skinnier. And plus 5 tells us that it will actually be, all of the coordinates will be shifted up by 5 units. So let's plug in some numbers. Let's start with 0 and see what happens. So 0 squared is 0. Times negative 2 is still 0, but we have to add 5. So that becomes 0, 5. So we already know that it's not starting at 0, 0, so it's been shifted up by 5 units already. Let's try 1. 1 squared is 1. Times negative 2 is negative 2. So right now it would be at 1, negative 2. But then we have to add 5 to that. So that would be 1, 2, 3, 4, 5. That would be at 1, 3. So now let's try that negative 1 to see if there's symmetry. Negative 1 squared is positive 1. Times negative 2 is negative 2. And negative 2 plus 5 is 3. So we do have symmetry. That tells us that 0, 5 is our vertex. Let's plug in our 2. 2 squared is 4. 4 times negative 2 is negative 8. And then we have to add 5. We get negative 8 plus 5 is negative 3. So we're at 2, negative 3. And with symmetry, we'll be at negative 2, negative 3. And let's try 3. 3 squared is 9. Times negative 2 is negative 18. And then negative 18 plus 5 is negative 13. So 3 will be at negative 13. And with symmetry, we'll have negative 3 at negative 13. So we can connect our coordinates. So this graph did flip the parabola. It is pointing down due to the negative. This parabola is more narrow, and it grew much faster than a parent function would because of the 2. And it did shift all the coordinates up by 5 due to the plus 5 at the end. So all parts of this, these are the basic shifts where we did not focus on any B value. It was just the A and the C. So what do the A and the C really do? That's what this video was all about.